All right, lesson 6-10, spheres, page 324 in your book. First of all, take a look at how you draw a sphere, just to make sure you understand this. You draw a circle, then you see that this circle here is the front of the circle, and then behind it here is the hidden circle that's kind of the halfway point of the overall circle. So it's really like a ball or a globe, okay? So let's get rid of the yellow quick. All right, so now what do we talk about the pieces of a sphere? Remember, as a ball, there's a center point. The center point, right here, is always exactly the radius distance from every outside edge of the ball, okay? So the sphere has a radius, just like a circle has a radius, except instead of the circle being a flat two-dimensional figure, a sphere is three-dimensional, with every part of the sphere being exactly the radius distance away from the center point. And that's what's called a sphere. Okay, if I cut a sphere in half, it's called a hemisphere. And hemi is just a special word for half. And this picture up above, right here, is the picture of half of a sphere, or a hemisphere. And you'll notice that the edge that's left, right cut at the half, is the center circle. That is the biggest the circle's going to get. It's exactly a one radius out, and that is called the great circle. Okay, and if you look at different applications, the great circle can come into play. It's just a term to know for right now. So now we come to that. There's only two things that we're going to go over today, and one is the volume of a sphere, and the other is the surface area of the sphere. So we're not concerned about anything else, and the only thing you need to know when you're doing a volume or a surface area is you need to know the radius. So in our top example, our radius is 3. In our bottom example, when we're going to do surface area, our radius is 2. It's the same drawing, it's just the unit of measure is a little different. So now, when we go to the volume, this is the formula. The volume of any sphere is 4/3 pi r cubed. Okay, and since r is 3 over here, we substitute 3 in for r, and we have 3 cubed. 3 times 3 is 9, times 3 again is 27. Then I divide that by 3, I get 9 again. I multiply it times 4, I get 36 pi units cubed. And notice it's the units cubed because it's a volume measurement. So every volume measurement of a sphere, all you need to know is r, radius, and you're going to cube it, multiply it times 4/3 and pi. For surface area, the formula is simply 4 times pi r squared. Well, now the only thing you need to know is r, and in this example our r is 2, so 2 squared is 4. 4 times 4 is 16, and there's my final answer, 16 pi units squared. But once again, it's not units cubed, it's not volume. Surface area is an area, so it's just units squared. So those two formulas is what you need to remember. That formula right there, and that formula right there. That is the whole lesson, is learning those two. When you're doing a sphere, you do the top one, the V equals 4/3 pi r cubed. When you're doing surface area of a sphere, you do the bottom one, surface area equals 4 pi r squared. So let's do an example where we're asked to find the volume. Well, we know that on this drawing, our radius is 6, so our formula, 4/3 pi r cubed, becomes 4/3 pi 6 cubed. And when I multiply that all out, I get 288 pi meters cubed. Now, on the right-hand side, it says do the same sphere, this time find the surface area. So I'm using the other formula that we learned, 4 pi r squared, for 6 squared. 6 squared is 36. 36 times 4 is 144. And so I end up with 144 pi meters squared. Once again, we have meters cubed for volume, meters squared for surface area. So now let's just do a little comparison. I'm going to compare two different things. One, a sphere with a radius of 21 centimeters. Another is a rectangular prism of 28 by 32 by 42 centimeters. You'll notice that if my radius of my sphere is 21, double that is 42. So this rectangular prism is approximately the same width as the whole sphere, okay, or same height as the whole sphere, okay? And the width and the length of it are somewhere near the same size of that radius, so it kind of fits inside the sphere, but not quite. They're pretty equivalent. And that's what we're trying to do, is show two here that when we calculate the volume of a sphere, and we take 4/3 pi r squared, and when r is 21, we end up with this large pi number, and that gives us basically, when we multiply times 3.14, 38,772 centimeters cubed is the volume of that sphere. Now remember, this rectangular prism on the right, its formula for its volume is just width times length times height. So we take the three numbers, multiply them together, and we get 37,632 centimeters cubed. So those are approximately equal. These two numbers are close, comparable. So we have basically a sphere and a rectangular prism that hold about the same amount of stuff. So now let's take a look at their surface area. The exact same items, but this time we're going to deal with the surface area. Well, different formula, pi r squared for the sphere. R is 21, so 21 squared times 4 ends up with 764 pi, and I multiply that times 3.14, and there is our answer, 5539 centimeters squared. When I go over to the rectangular prism, I need to look at the fronts and the back. That's what 2 times length times width is. I need to look at length times height. That'll be the edges, and width times height will be the top and bottom. And when I multiply all those out and add them together, I end up with a 6,972 centimeters squared. So there's no real relation here, other than we're trying to point out the fact that even though these two items are kind of the same, here, approximately the same, they are not too similar in surface area. You'll notice that the rectangular prism has quite a lot larger surface area. So there's no one relationship. If the volume of two shapes equal each other, that does not mean that the surface area has that same relationship. So you have to calculate them all out. And that's really the lesson, is learn how to do this. I'll come back to look at it right here. Volume and surface area. These two formulas that I've pointed the arrow to are the lesson, and that's what you need to learn.